Here we have a solids of revolution problem. Specifically, the region bounded by y equals the square root of x, y equals 0, which is the x-axis, and the vertical line x equals 4 is revolved about the x-axis, and we want to find the volume of the resulting solid. So y equals the square root of x is the upper half of a parabola opening to the right, and we revolve this about the x-axis. So we get part of a paraboloid. I want to figure out the volume of this object. We're going to approximate the volume using a sequence of disks. Here's this from another angle. I have roughly 20 disks total. Okay, here's an illustration of the ith disk. Here's a subscript, and it's going to go from 1 to 20. And this ith disk has a radius y sub I and a thickness change in x. So its volume is a cross-sectional area times the thickness. So we get our v sub I is pi y sub I squared change in x, but we want this in terms of x. Y sub I is square root of x sub I, so we substitute that in there and simplify a little bit. We get v sub I is pi x sub I change in x. So our volume of this solid is going to roughly be the sum of these 20 disk volumes. And I can write that in sigma notation as the sum I equals 1 to 20 pi x sub I change in x. And what's going to happen is as we take more and more disks that are thinner and thinner, we get the actual volume as a limit here of these Riemann sums. And that becomes a definite integral. Recall that x is going from 0 to 4. You can also note that the pi x sub I change in x became pi x dx. We use a fundamental theorem of calculus using the fact that the antiderivative of x, we have 1/2 x squared. And we put the 4 and the 0 in there, and our final answer we have 8 pi cubic units. And this is kind of amazing because what we did is we found the volume of this solid essentially just knowing the volume of a disk. Thank you.